Today in this video we are going to solve the past question papers of the Punjab University from the Calculus with Analytic Geometry book. Come on page number 4. The theorems that are given on page number 4, part 4. We're going to just discuss this theorem. If a is greater or equals to 0, then absolute value of x is less or equals to a. If and only if minus a is less or equals to x is less or equals to a. If whenever you need to prove a theorem in which you have an if and only if condition, you have to consider its one side and prove the other one. And then conversely take the last side and prove the first side. So here the solution is also given. First of all, consider the left side, that is x mod is less or equals to a. You know that x is less or equals to a if x is positive. And if x is negative, we can write it like minus x is less or equals to a. Then now from equation number 2, multiply the negative sign on both sides, and you know that if we multiply the negative sign on both sides, the sign that is here, the less than or equals to, that changes into the greater or equals to, and it will become like x is greater or equals to minus a, and that can be written as minus a is less or equals to x. So from equation 1 and equation 2, you can write a combined equation, that is minus a is less or equals to x is less or equals to a. So starting from this point, you proved your right side. Now consider this right side and prove this left side. So here conversely, you have to consider this proven side. Now you can separately divide it into two inequalities. Like you can write it like minus a is less or equals to x and x is less or equals to a. So separately write it like this. Now this equation number 4. This equation number 4 can be written as minus x is less or equals to a. Just multiply the negative sign on both sides and write it like this. Now from equation number 5 and 6, from last two equations, you can write like absolute value of x is less or equals to a. Now come on example number 3, part 2, that is on page number 7. You have to solve this inequality, absolute inequality. For solving the absolute inequality, you need to separate it into two parts. And how we can separate it? We know that we can write it like 5x plus 6 is greater or equals to 5, and write one more time the same equation. 5x plus 6 is greater or equals to 5. Now simply you have to do what? First of all, you have to separate the same equation without the absolute. Now take this as the positive one and take this as the negative one, and now solve it. You know that we can write it like 5x plus 6 is greater or equals to 5. Just separate your x variable from here and just eliminate the terms that is with the x. So you see 6 is added with it, subtract it on the other side. You will get here 5 minus 6, that will be 5x is greater or equals to minus 1. Now x is greater or equals to minus 1 over 5. Now come on your right side. This will be minus 5x minus 6 is greater or equals to 5. You will get minus 5x is greater or equals to 5 plus 6. So minus 5x is greater or equals to 11. Now we need to just move this negative 5 here. Whenever we move the negative sign that is in multiplication and that is in division, this change this inequality. Now it will be x is less or equals to, opposite to the previous inequality, 11 over minus 5. So this is x is less or equals to minus 11 over 5. Now we need to write the solution. We know that x is greater or equals to minus 5, and here x is less or equals to minus 5. We can write our solution set into two ways. Solution set equals x belongs to set of real numbers such that you can write it like x is greater or equals to minus 1 over 5, or x is less or equals to minus 1 over 5, like this. Or we can also write it like, you see here, the x is less than negative 11 or 5. If you draw a number line, then this will be minus 11 over 5 and this will be minus 1 over 5. So moving x is less or equals to, so the complete ball, and it is on this side, and x is greater or equals to minus 1 over 5, so it will be on this side. So we can write it like from negative infinity to this point, it will be written as negative infinity to minus 11 over 5 close interval here, because this is equality as well. And infinity, you know that always we draw the open interval here with the infinity. Union minus 1 over 5 to positive infinity. So this is the answer for your this example that is given on page number 7. Example number 4 part 1 that is given on page number 8. X square minus 5x plus 6 is less than 0. Now here we have a quadratic equation here. First of all, we will write its associated equation. Associated equation will be, just remove this inequality and write the equal sign. This will be x square minus 5x plus 6 equals to 0. Now factorize it. After the factorization, we'll get here x minus 2 multiplied by x minus 3 equals to 0. Now separate it, we will get x minus 2 is equals to 0 and x minus 3 is equals to 0. And this will give us x is equals to 2 and x is equals to 3 here. So here we have 2 points, boundary points. These are the boundary numbers for the given equality. So our real line, if I draw a real line here, I will get here 2 and here I will get 3. So divide the number line into regions. From here negative infinity to 2, I will call it region A. From 2 to 3 the region B, and from 3 to positive infinity I will name it like C region. Now we will just test the regions into the given inequality and we will observe its behavior. From region A, negative infinity to 2, take any point. Consider any point here. You know that points here on the left side are 1, 0, minus 1 and up to so on. You can take any point from this region and put it in this inequality and check whether this point holds here or not. So from region A, let x is equals to 0 and put in it. We will get here 6. And what is given here? Less than 0. This is false. We know that 6 cannot be less than 0. So it means our region A is not included in our solution. Now from region B, take any point out of this. I am taking here 2.5. Let's suppose. From region B, I am let x is equals to 2.5 and put the x value here. We will observe that this 2.5 square minus 5 times 2.5 plus 6, the answer will be less than 0. And that is true. You will just solve it using your calculator. You will get the answer that is less than 0. So it means this region is included in our solution region, the region B. Now from region C, take any point after the 3. Let x is equals to 4. Put in it. We'll get here 16 minus 20 plus 6. That will also be less than 0. That is false, because we know that 16 minus 20 will give us minus 4. Minus 4 plus 6 will give us 2, and 2 cannot be less than 0. So this statement is false. So it means region C and region A is not included in our solution region. Only region B is included. So solution set will be the open interval. Because you see here we don't have the equality sign, we will write it like open interval 2 to 3 like this. Or you can also write it like x belongs to set of real numbers such that 2 is less than x is less than 3. So this is our solution set. Now come on the page number 9. On page number 9 we have example number 5. That is x square minus 2x over 1 minus 2x is greater than 1. Now make its associated equation. Its associated equation will be x square minus 2x over 1 minus 2x equals to 1. The inequality will changes into equal if you write the associated equation. Now solve it. We'll get here x square minus 2x is equals to 1 minus 2x. Move it on the left side. We'll get here x square minus 2x minus 3 is equals to 0. Now after factorization, we'll get here x plus 3 into x minus 1 is equals to 0 here. So we can write it like x plus 3 is equals to 0 and x minus 1 is equals to 0. And out of it, we will get x is equals to minus 3 and x is equals to 1. So these are our boundary numbers. These are our boundary numbers. And one more thing I can conclude from this question, that we have a fraction here. And we know that we have some limitation in fraction. And what is that limitation? That our denominator, the denominator cannot be equals to 0. That is 1 minus 2x cannot be equals to 0. So it means minus 2x cannot be equals to minus 1. So it means that x cannot be equals to 1 over 2. So this is my free boundary number. This point cannot be included in the solution because on the value of this x value, this term will become undefined. So just draw the regions on a number line. You have minus 3, 0.5 and 1. It will be minus 3, half, that is equals to 0.5 and the 1. Now from this to this region we name it like A, B, C, and this region is D. Now check all the regions here. If we check the region A, let's suppose x is equals to minus 4. On the left side of minus 3, take any value. Let's suppose x is equals to minus 4. This will give us 16 minus 2 over 1 plus 8 is greater than 1. The answer is greater than 1. This is true. Now from region B, let x is equals to minus 1. Between minus 3 and 0.45, take any value. I took x is equals to minus 1, put in the main equation inequality, we'll get here 1 minus 2 over 1 plus 2 greater than 1. That will give us the false answer. Now it means this region is not included. Now region C. Region C, let x is equals to 3 by 4. Put in that inequality. In this inequality we'll get here 9 by 16 minus 2 over 1 minus 3 by 2. That is greater than 1. This will give the real answer greater than 1. So it means the region C and region A are included up till now. Now check the region D. Let x is equals to 2. Here we will get false answer. So it means the D is not included. So our solution set is now A region, that is minus infinity to minus 3. So it will be written as minus infinity to minus 3 union which region? 1 by 2 to 1. This region. So this is our solution set here for example number 5. Now come on exercise 1.1. I told you earlier that question number 12 and 14 are important, that have came earlier in the past papers. So just attempt this question number 12 for the revision purpose. Now this is an absolute inequality. Consider it as x square, like consider its associated equation. The associated equation will be x square minus x plus 1 is equals to 1 here. Now factorize it. After factorization we will get here x into x minus 1 is equals to 0, because this 1 and this 1 will be cancelled out. Take the x common, we'll get here x into x minus 1 is equals to 0. So we'll get x is equals to 0 and x is equals to 1. So these are our boundary numbers for this given number. Now draw the number line. If I draw the number line here, I will get here the region, this region A, and the second boundary number is 1. So this is region B and this is region C. Now check your all regions in the given inequality. This inequality, this associated equation is for this absolute value for the positive one, because we know that we can take out the two inequalities out of it. The one is x square minus x plus 1 is greater than 1, and the other inequality will be minus time x square minus x plus 1 is greater than 1. And out of the second inequality we can write it like x square minus x plus 1 is less than 1 if I just multiply the negative sign on both sides. So I am doing this work for this inequality number 1, and for inequality number 2 I will do it separately. So check this regions now, and this regions are for this inequality number 1. So for x is equals to region A, let x is equals to minus 1. Put in that equation, we'll get here 1 plus 1 plus 1, and that is greater than 1. So it is true. So it means our region A is included here. Now for region B, let x is equals to 1 by 2 here. So after putting this value in this inequality 1, we will get here 1 by 4 minus 1 by 2 plus 1, that is greater than 1, but this will give us the false answer because that answer is less than 1. So our region B is not included. Now for region C, let x is equals to 2, greater than 1. Take any value that is greater than 1. Let x is equals to 2, put in that inequality 1. We'll get 4 minus 2 plus 1 is greater than 1. That is true. So it means region C is included. So the solution set for the first inequality, this inequality, will be minus infinity to 0 and 1 to infinity. So we can write it like minus infinity to 0 union 1 to positive infinity. Now consider this second inequality, that is minus time x square minus x plus 1 is greater than 1. Now remove this negative sign, multiply it on the right side. We'll get here x square minus x plus 1 is less than minus 1. Now this will become x square minus x plus 1 is less than 0. This will give us x square minus x plus 2 is less than 0. This will give us undefined roots. The roots that are not defined, not real roots, are given in this case. So it means we will not get any solution set out of this. So our main solution set is this one. Now move on to question number 14 of the same exercise. 2x over x plus 2 is greater or equals to x over x minus 2. Now we need to find out the value of x out of this inequality. Just solve this equation. How? Just take its associated equation. 2x over x plus 2 is equals to x over x minus 2. Multiply, the cross multiplication will give us 2x times x minus 2 is equals to x times x plus 2. So 2x square minus 4x is equals to x square plus 2x. So this will give us 2x square minus 4x minus x square minus 2x is equals to 0. So out of it I will get x square minus 6x is equals to 0. So x times x minus 6 is equals to 0. So we'll get here the boundary numbers are x is equals to 0 and x is equals to 6. So these are the boundary numbers. One more thing, we can get the free boundary numbers out of this because we see we have fractions and the denominators cannot be equals to 0. It means x plus 2 cannot be equals to 0 will give us x cannot be equals to minus 2. And x minus 2 also cannot be equals to 0. So this will give us x cannot be equals to 2. So these are our free boundary numbers. And these 2 points are our main boundary numbers. So we'll just draw a number line. On the number line we'll get here minus 2, 0, 2 and 6. Now this minus 2 and this 2 is our free number, free boundary number. Now this is region A, this is region B, C, D and E. Now check all the regions, take any point out of these regions and put it in this inequality and observe the behavior, whether this term is exactly greater or equals to this one or not. If it is greater or equals to, then this region is truly included in your solution set. If the value of x does not hold this inequality, this means that that region is not included in your solution. So after just finding the values and just pick the values, put it in this inequality, and after checking, I will get that my region A is included, region B will not be included, region C is included, region D is not included, and region E is included. So the solution set will be minus infinity to minus 2 union 0 to 2 union 6 to positive infinity. So this is my, due to this equality, this point 6 will give us this closed interval here. because on 2 we have an open ball, on this 2 we have open ball, and on 6 we have a closed ball here. So due to this closed ball, because this 6 is included, so we will draw here like closed interval here. So this is a solution for our question number 40. Now exercise 1.2 contains the important question that was already came in one of the past year paper, question number 24. Evaluate this limit x approaches to -1, x raised to power 1 over 3 plus 1 over x plus 1. This can be evaluated as, we can just break this. If I directly put this limit here, this will give us the undefined answer. So I'm just breaking this limit into some other point. I can just convert it into limit h approaches to 0. Now in place of x, I can replace it with a plus h. And what is a? This limit is our a. So, and the limit will convert into 0. The limit h approaches to 0. Now replace x with a plus h. This will give me -1 plus h raised to power 1 over 3 plus 1 divided by, in place of x, -1 plus h, and this plus 1 will come as this. This my 1 and -1 will be cancelled out. We'll get here limit h approaches to 0. Now I am taking the negative sign common because the power can be the odd one. Take the negative sign common. I will get here inside 1 minus h raised to power 1 over 3 plus 1 divided by h here. Now limit h approaches to 0. Just expand this expansion. We can expand it like the first term plus the power and the second term plus power minus 1 square of the second term divided by 2 factorial plus up to so on divided by h, and we have plus 1 here as well. Now this can be simplified as limit h approaches to 0. Upside will get here. Now multiply the negative sign as well inside and open it. Simplify it. We will get here -1 plus h over 3 plus 1 over 9h square plus up to so on, and outside we have plus 1. This plus 1 and -1 can be cancelled out. We'll get here limit h approaches to 0. Take h common from here and cancel with this h. We'll get here 1 over 3 plus 1 over 9h plus up to so on. Take h common and cancel it with the denominator. Now we can easily apply the limit. We'll get here 1 over 3 plus 1 over 9 into 0 plus 0 plus up to so on. So the answer for this limit is 1 over 3 now. Now question number 36 of the same exercise. Let f of x is given here. This is a piecewise continuous function. X plus 2 if x is less or equals to -1, and ax square if x is greater than -1. We need to find out the value of a so that the limit exists. Limit exists in only one case. And what is that case? If the left hand limit equals the right hand limit, then our limit exists. So in this question, we need to find out our left hand limit and we need to find out our right hand limit, make them equal and find the value of a. The left hand limit, limit x approaches to -1, left hand means the negative sign here. F of x. Left hand side means the negative values of this -1. Approaching the values from the left side. So this is basically less than -1. So you will take the function here x plus 2. So this will be limit x approaches to -1 minus, and the function will be x plus 2. Replace x with this minus. We'll get here -1 plus 2. So this is 1. Now the right hand limit. For the right hand limit, approach the -1 from positive side. And from positive side, it must be the greater than to that limit. So consider this function. It will be limit x approaches to -1 plus, that is ax square. Now put the limit in this in place of x. We'll get here a times -1 square, and this will give me a. So since the limit exists, therefore the left hand limit will be equals to the right hand limit. Now make them equal. We'll get here 1 is equals to a. So this is the answer for our a value here. Now come on page number 40, example number 36. let f of x equals x sine 1 over x if x is not equals to 0 and 0 if x is equals to 0. We need to examine its continuity of f at x is equals to 0. For that purpose, we know that the definition of continuity, that the limit must be equals to the direct limit, the direct point in that function. So the limit x approaches to 0 f of x is approaching to 0. It means x is not exactly equals to 0. So consider this first function, that is x sine 1 over x. Now separate the limit. We know that if we put the limit here, this x will become 0 and this will make this term completely equals to 0, because we know that the sine values are always bounded between 1 and minus 1. So we'll get here some bounded answer, and 0 multiplied by that bounded answer will be 0. And that is exactly equals to, if we directly put x is equals to 0 in that function, we'll get here 0. So the limit equals the f of 0. So f is continuous at x is equals to 0 here. Now come on exercise 1.3 and we need to do this question number 15. For the continuity of function, we know that what is the definition? That the limit x approaches to at which point? 0. F of x must be equals to f of 0. If this condition holds, then we can say like our given function is continuous. So first of all, we need to calculate this. Limit x approaches to 0 f of x. X is approaching to 0, not exactly equals to 0. So that means we need to consider this function. So this is equals to limit x approaches to 0 x square sine 1 over x. We can write it like limit x approaches to 0 x square into limit x approaches to 0 sine of 1 over x. We know that our sine function is a bounded function and its value will always be between minus 1 and 1. So if we just put the limit here 0, this 0 multiplied by this bounded answer will give us the answer 0. And if I just consider the direct value, put the direct x is equals to 0 in the function, that is x is equals to 0 for f of x, that is equals to 0. So this will give me 0. So from equation 1 and from equation number 2, we can say like limit x approaches to 0, f of x equals to f of 0. So the given function is continuous at x is equals to 0. Now question number 21 from the same exercise 1.3. Find the constants a and b such that the function f is defined by this given function is continuous for all x. Now we can see from this function values, the limit values, we can see we don't have the equality here and also we don't have the equality here. It means this function can be continuous except at minus 1 and 1 for the values of x. So consider these values. So we can say it like the given function is continuous for all x possibly except at x is equals to minus 1 and x is equals to 1. So we will check the limit. For the continuity, we will just check its existence of limit on these points. So for the continuity, first of all, we'll just write its existence of limit. For that purpose, check its left hand limit on this point and right hand limit on this point, make it equals to 0. So we'll just say it like limit x approaches to minus 1 from the negative side approach, that is your left hand limit. That is this point, x cube. So it will be, consider this function, limit x approaches to minus 1 negative x cube. This will be minus 1 cube and this will give us minus 1. Now the right hand limit, limit x approaches to minus 1 plus f of x equals limit x approaches to minus 1 plus. Now x must be greater than minus 1. Where it is? X must be greater than minus 1, this point. So we will take this function, that is ax plus b. Put the value here for x, we'll get here a times minus 1 plus b. This is minus a plus b. Now the function will be continuous if we have 1 equals to 2. That is minus 1 equals to minus a plus b. So let's suppose this equation as equation number 3. Now check at x is equals to 1. limit x approaches to 1 negative side. Now 1 negative means the left hand limit. X must be less than 1. X is less than 1 at this point. So ax plus b. Consider this function ax plus b. Replace x with this limit. We'll get here a plus b. Now consider the right hand limit. Limit x approaches to 1 plus f of x. This means x must be greater than 1. And x is greater than 1 at x square plus 2. Replace the x with this 1. We'll get here this one, that is equals to 3. Now the function will be continuous if this one will be equals to 3, that is a plus b will be equals to 3. So this is, let's suppose, equation number 4. Now add equation number 3. Simultaneously we will solve both of the equations. Adding equation 3 and 4 will give us the value of a as 2 and then use value of b as 1 and use that value of b in any of the equation and get the value of a. That is, a is equals to 2 and b is equals to 1. You will get from these two equations, solving these two equations simultaneously. Now come on question number 31 of the same exercise 1.3. We have to check its continuity, the continuity of this function at x is equals to 0. For that purpose, first of all, we check its limit. If the limit exists, then we can say like the function is continuous and then we will proceed. If the limit is not existing, it means we can say it at that point, stop your question at that point and write like the function is not continuous, it is discontinuous. So first of all, check the limit. Limit x approaches to 0 minus left hand limit f of x. This will be equals to limit x approaches to 0 minus e raised to power 1 over x over 1 plus e raised to power 1 over x. Now the limit is this, x is approaching to 0 from the left side. It means I am solving it separately, this point. It means when x approaches to 0 minus, this means that 1 over x approaches to negative infinity because it is approaching from the negative side. So the 1 over x will approach to negative infinity. So this means e raised to power 1 over x will approach to e raised to power negative infinity. And that is equals to 1 over e raised to power infinity, and that is 1 over infinity will give us the 0. So this means that we will get here 0 over 1 plus 0, that is equals to 0. Now the right side approach, limit x approaches to 0 plus f of x, that will be equals to limit x approaches to 0 plus e raised to power 1 over x over 1 plus e raised to power 1 over x. This will give us, now put the 0 here, we'll get here 1 over 0, that is infinity. So we'll get here infinity over infinity form. So you see your left hand limit is not equals to right hand limit. Thus limit x approaches to 0, f of x does not exist. Since the limit does not exist, this means given function is not continuous, or you can say like the given function is discontinuous at x is equals to 0. So these were all the important questions from the past papers from the chapter number 1.